Yeah, that's fine. Hello. I would like to thank Tim and Melanie for inviting me. You know, it's a pleasure to be here. I'm very honored to be in a coffee event of this level and present my results. I do not work with coffee. I am a neuroscientist. I've been trained in biology with a master's in biochemistry and a PhD in psychobiology, studying perception. So what I've been looking for the last 20 years is the neural basis of perception. What happens in your brain when you perceive things. So we get to know about the world through our sensory apparatus, right? So the senses of touch, sight, taste, smell, and audition. They all provide us with information about what is out there in our environment and regarding chemical and physical phenomena that's out there, right? And some of these physical and chemical phenomena can activate receptors we have in our sense organs. And this information is used by our brains to build up what we call reality, what we call a perceptual experience. So flavor is one of those experiences I'm talking about. So flavor is not out there in the world, flavor is in here. We build up it. Better say, our brains build up it. What I'm trying to say is that this sweetness is not in the glucose molecule. This is just a molecule. It's just C6H12O6. The sweetness happens when it binds the receptor and activates it. So there is an electrical impulse that goes to a specific part of our brains, and then we experience that something is sweet. Okay? So our five senses, through our five senses, we can experience color, shape, tone, pitch, texture, temperature, the basic tastes, and odors. However, this information coming from each one of the senses is very fragmented in the brain. So we have the what the sense organ, the eye for vision, captures. It goes straight to one area in the brain that's called the visual cortex. So we have it here. And the same happens for all our five external senses, right? So we have very specific, highly specialized areas that deals with information coming from each one of these five senses. So you have here for vision, for audition, the somatosensory is tactile, for taste, and for olfaction, right? We call those areas unimodal because they only handle, they can only see, let's put like that, one type of information. They are blind to all other ones. So if I give someone an auditory stimulation and measure the activity of the neurons in the visual cortex, they will be quiet. So there will be no activity over there. Okay, because they are highly specific to vision. This information, so this very specific information then goes up the cortical, we say hierarchy, from unimodal areas to multimodal areas. So all this area around the sensory cortices integrate the information between two or more senses. So we have bimodal areas and multimodal areas. And the external senses, they are either physical senses or chemical senses. And regarding flavor, we have three main senses that participate in the construction of this percept. So both chemical senses are part of it, right? And also the somatosensory perception. Yes, so here it is. So we have the tactile, we have the olfactory, and we have the gustatory system. So all the senses, they are somehow in the mouth, right? And regarding olfaction is what we call retro-olfaction. That's the volatiles of food or drink that are within our mouths. And when we chew or when we move these things round about our mouth, we release those volatiles and they can get to the olfactory epithelium and we can smell them. So these things get in the brain at the same time, so they're combined. Okay, I have touch, in this case mouthfeel, I have mouthfeel, I have the basic taste, I have olfaction, so they must be coming from the same thing. So we have the construct of flavor because of that. But these three senses are intrinsic to the food, but we also have modulation from the other systems, okay? So you have the visual system, the auditory system, and the ortho-olfaction also modulate flavor because they set up our expectations. When we see food, when we hear something that has a texture that really I don't know, like something you can break and make a noise. So it sets you up towards texture, right? And the aroma of things. So you are expecting things there. And all those senses, the taste, the retro-olfaction, the mouth-feel, vision, and audition, they all merge, they all converge to this part of the brain that we call the orbital frontal cortex. It's an association cortex where flavor is built. In the orbital frontal cortex, we also have the affective information coming up. So it's not only sensations, but also emotions and reward perception related to that food. And the conscious experience of flavor happens here too, okay? Everything that happens from this bit back, so everything that happens in this part of our brains, we are not aware. So things are being dealt with, they are being associated, there are lots of spikes going on, but it's not accessible to the subject of the perception, okay? So we are not aware of what's going on. Only if things get to this prefrontal cortex, regarding flavor is this part, the orbital frontal cortex. Okay, so far I've said that you have the physical and the chemical stimuli in the environment. They hit the sensor organs, and then they are carried to the basic sensory areas, and they get associated in multimodal areas, and then we perceive, right? This is what we call bottom-up type of the brain handling things. So we start with the specialized cortex going up the hierarchy to integrative cortices. But we do not perceive things like that. We are not pure. We are not totally clean of expectations. when we taste things. If I come here and get this glass of water here, you know, that's the first time I'm seeing this glass, this specific one, but I know exactly what to do with it. I know how to interact with it. I know the pressure I have to put in my hands to get it. I know how to drink the water. I know the taste of the water because I've done this so many times in my life that I have expectations. So the brain learns, you know, when you put the subject in the same context. So lots of times the subject would learn about it. So we build up expectations. That's what we call internal models. So we have internal models that tells me what to expect about the world. So we are always anticipating things. We say that our brains are one step ahead of us. So if I get this glass of water here, my brain knows what to expect regarding taste. So my gustatory cortex sometimes is already activated only when I am expecting someone to come to my tongue. So before it hits my tongue, I'm already sensing it because the expectations can be really high. And we call this top-down handling of information. So you have higher cortical areas modulating the low cortical areas. And we are much more in the top-down side than the bottom-up side. Okay, we have much more expectations about how the world is, and actually building up sensations that sometimes is not there, but because we think it's there, so it's there. So we simulate reality, so to speak. And we say that we perceive the world in an inferential way. We make inferences all the time. You know, given what I know, what's the probability of this being a glass of water? Well, it's very high. You know, my internal model to detect glasses of water is very, very good because I've been doing it since I'm a little kid. So we say that the brain does not approach the world by asking, what is this? But asking, oh, what does it look like? So we have a model, we have lots of models. And when we perceive things, actually we try to fit that new event to a box, to a set we already have. So we are doing it all the time. We are never pure. And the brain combines sensations. I said in the beginning that the brain handles things in a very fragmented way, but it combines in bimodal and multimodal area before it hits the orbital frontal cortex, before we have the holistic experience, right? So these internal models trigger expectations due to already learned associations about stimuli from different modalities due to statistical regularity. So if I ask you guys which group has a greater probability of being sweet, you're going to say the red one. And if I ask which group has a greater probability of being sour or bitter, you're going to say the green one. It's because we have associated color with basic tastes. So if we see a food or a drink with that color, we are approaching it already with lots of expectations towards how that is going to taste, right? This is what we call cross-modality or cross-modal perception. So there is a crossover of information in your brain when it is building up reality. So the way the brain combines things. Cross-modal perception happens when stimuli presented in one sensory modality influence the perception of stimuli presented in another modality. If I give you guys a sugar solution with the same concentration, but I dye one in red and the other one in black, I'm sure the majority of you will hate sweetness higher in the red one than in the black one, right? Because there is expectation. What does it mean to have expectation? It means to put your brain in a mental state, in an attentional state towards that thing. So if I give you something pink or something red, I'm putting the subject in the sweet mode. So all the attention will be channeled to sweetness of that food or that drink. If there is sweetness there, the sweetness will be perceived as very low. It is as very high. Okay? Because the person will enter that food or that drink via the sweet bit of it. And the cross-modal perception can be of two types. That's what we call cross-modal bias. We have the super additive, when the two stimuli go together, like when I see a cat and hear meow meow. Okay, my brain's happy with that. I have a strong response in the orbital frontal cortex. My brain's happy because it's relaxed. Okay, my internal model is up to explain the world, right? But if I see a bird and the bird says meow meow, then there's something wrong in there, because those things, well, as far as I know, as far as my statistical sampling of the world knows, they don't go together. So there will be a weak response in the orbital frontal cortex. The expectation will be broken here for the subject too. Okay, we don't like this. We like this. We like when our expectations are fulfilled. Well, up to some point, because this is boring, right? We would like to be exposed to some novelty too, but we need to be careful about that, otherwise we get anxious about novelties. Well, the brain gets anxious. Okay, so let's see a little bit of cross-modal perception. This was the first cross-modal effect reported. It was done in the 30s by a German psychologist, and he described this Buba-Kiki effect. If I ask you to name these two shapes, which one will be Kiki and which one will be Buba? It will be Kiki, Buba, right? Yes, 95% of people say that. This is obviously Kiki. See, Kiki has a sharp sound. Well, sounds are not sharp, but we are very comfortable in describing them like that, because there is this crossover thing, okay? And this is Buba. See, Buba is round and fatty, it's Buba. And if we pay attention, even how we write it is round and it's sharp. There are linguistic people studying it too, you know, the sound and how we write it down. Okay, so this is the first effect and is a cross-modal association between shape and sound. And we can even go further here. And if we abstract this Buba-Kiki thing, we can classify things in the world as being Kiki or being Buba. If we go to papaya and lime, you know, papaya is more Buba, where lime is more Kiki, right? Because it's sharp. Still water and the sparkling water. The sparkling water is Kiki because it's a little bit sharp. There is this gassy sensation, and the still water is more Buba. And the carrots, well, you can slice them as Kiki or as Buba, but does it has an effect on taste? It turns out that yes. So there is an association between shape and taste. Kiki is perceived as more sour or bitter, whereas Buba is perceived as sweeter. So there is this beetroot test where they slice the beetroot as kiki or as buba, and it was perceived as sweeter when they were in the buba shape. And the chocolate was also perceived as sweeter in the buba shape. And this is the latte art test that they done in 2005. And they found out that the kiki shape made it taste a little bit bitter. That's funny, isn't it? Who would think? Okay, and there is also cross-modal association between color and taste. So this is a review showing studies which approached the subject starting in the 80s. I think the first one was in 83 in several countries. So here we have 70 countries in this study, 4 countries here, USA, Germany.